This is chapter 8, section 5. Chapter 8, section 5. Get my pen going on here. All right. So 8, 5. This is the variation functions. Now, there's a handful of these. The hardest part about these is knowing which formula to use and where things go. The math in this is not hard, right? So, here we go. The first type of variation is direct variation. Direct variation. And when we have direct variation, then we would say something like y varies directly. Can't spell today. Directly as x. And that yields the following formula. Y equals kx. And k stands for the constant of variation. The constant of variation. All right. Now, the type of problem that you'll run... Oh, are we going to have one of those? All right, there we go. Yeah, every now and again when I use this particular program, it does weird things on me. All right, here we go. So let's try this particular problem. Let's go with if y varies directly as x and y equals 15 when x equals negative 5, then I want you to find y when x equals 7. Okay. Let me read through that again. If y varies directly as x. Now, that phrase right there, right, should lead to the following formula. This phrase, y varies directly as x. That leads to the formula y equals kx. Y varies directly as x. Right? So, leads to that formula. Then the next thing that happens is they give you more information. They tell you that y equals 15 when x equals negative 5. Y equals 15 when x equals negative 5. I'm going to use that information to find, what am I missing? I'm missing k. Right? So I'm going to go ahead and plug in 15 and set that equal to k times negative 5. All right? I'm missing k. I don't know what my constant of variation is. Yes. This is pretty straightforward stuff. Right? As far as the math is concerned. Okay? Which means that k is equal to what? Negative 3. No, the book solves them differently. The book uses proportions. Okay? And you're welcome to do them that way as long as you set it up and know what you're doing. I find them annoying, so I'm not. If you ask me to set them up that way when I solve problems, I will. But the book goes through and sets up proportions. I find it easy enough, just find k and then use k to do the second part of the problem. All right? So, now what they're asking me to do is they are asking me to find y when x is equal to 7, right? And so I use the formula again, right? Y equal, that's not what I meant to do. Let's try that again. Let's use the pen. So again, y equals kx, right? And here I am given that I'm trying to find y. I know k is negative 3, and I know x is supposed to be 7. Negative 3 times 7 is negative 21. And there we go. We're done.
Wow.
Right? It's not bad. You get information and use it to find something. Then you use that something to find more information. Right?
More something.
Okay. So, along with direct variation, we also have what is called joint variation. And this one reads in the following way. Y varies, that's not how you spell varies. Y varies jointly as X and Z. And that yields this formula. It yields y equal to kx z. Yep, it is exactly the same, right? So we'll run one of these real quick. So if we tell you that R varies jointly as V and T, I want you to find R when V equals 2 and T equals 8 if R is equal to 70 when V equals 10 and T equals 4. All right, again, you have lots of information here, right? So just sort of start tackling it piece by piece, right? The first thing I need to do is look at the statement of, let's see, what color did I do that in before? Let's see, the first color we used was blue. All right, so the first thing I need is my equation, right? And I'll find that in the R varies jointly part of this. R varies jointly as V and T. That leads me to R being equal to K times V times T. All right? The varies can kind of become your equal sign, right? And then you basically use the order that you're given. So R equals K times V times T. And now I'm going to use that second part to, or not the second part, I actually use the last part to find K. They tell me that R is 70 when V is equal to 10 and T is equal to 4. So there's the pieces that I need. 70 is equal to K, which I don't know, and V, which is 10, and T, which is 4. And now we solve for K. So K will be equal to what? 7/4. 7/4. Good so far? Okay. So last but not least, they ask us to find R when V is equal to 2 and T is equal to 8. So now I go back into my formula. So I have, again, R equals KVT. And I am using the fact that K is 7/4, V is 2, and T is 8 to do a little math, do a little dance. 4 and 8 will go down to 2, which leaves me with R being equal to 28. Yes? No? We good? Okay. So, that is direct and joint variation. So now we have inverse variation. All right. So here we would say that y varies inversely as x. Y varies inversely as x, which yields the following formula. Y equals k over x. Now it's the same deal, right? Nothing's really changed. So let's try one. Let's play with the following problem. Let's go with if x varies inversely as y and x equals 24 when y equals 4, find x when y is equal to 12. Now, you have to be a little careful, right? You're seeing the same variables as what we saw before, right? Y and x, but notice that something is a little different here. What's different? Yeah, they're switched, right? My statement clearly says that x varies inversely as y, which means that my equation is x equals k over y. Okay? Whatever comes first in my statement goes first in my equation. X varies means that x is on the left-hand side of the equal sign. Okay? So, next we use the x equal to 24 and the y equal to 4 to find my constant of variation. And so we have 24 equal to k over 4, which means that k is equal to, say again? 96. Very good. K is equal to 96.
Looks like a fun number.
So now we're dealing with the statement, again, x equals k over y, but this time I am using the 12 to find the value of x, and so we have x is equal to 96 all over 12, which means that x is equal to 8. Make sense? Okay.
Cool.
Uno más. One more.
Oh.
What do you think this one is? Yeah. Say again? Almost. Almost. You're on the right track though, right? This one is called combined. Okay. So here we would say something like y varies directly as x and inversely as z, which leads me to the formula y equals kx over z. Yes, no? Okay, let's do one. Okay, here we go. So let's go with the problem. F varies directly as G and inversely as H. I need you to find G when F equals 18 and H is equal to -3. I am also telling you that, where'd it go? There we are. When sorry, not when, but if, I apologize, if G equals 24, when H equals 2 and F equals 6. A lot of information in these, right? Okay, so we start to parse it out. First thing I need is my equation, right? So I'll come up to that first statement up there. F varies directly as G and inversely as H, which leads me to F equal to KG over H. Make sense? Okay. Next thing I need to do is start finding, there we go, finding the next part. They give me G is equal to, that's not what I need. Let's go with the highlighter, shall we? G is equal to 24 when H is 2 and F is 6. So we'll plug all of that information in. So I have 6 equal to K times G, which is 24, all over H, which is 2. All right, so here I've got 6 equals K times 12, which means that K is equal to 1/2. Everybody with me there? Okay. Now I'm going to use that to find G. We're going to find G when F is 18 and H is -3. And so I go back into this formula. F equals KG over H. F, they said, was 18. K, we know, is 1/2. G is what I don't know. And H is -3. So far, so good? Okay. So, now we solve. That means that I'm going to have -54 is equal to 1/2 G, which means that G is equal to -108. Now, before I move on, does anyone have issues with how we solved any of these? We good? Okay. So, here is what I need from you today. I have some bookwork for you. I also have a packet I'm going to get you. The bookwork today is on page 566. I'm asking that you do numbers 1 through 6. In the packet or the worksheet that you are getting, I'm asking that you do numbers 9 and 19. Now, the packet that you're getting, before you get up and start taking pictures of the book, the packet that you're getting involves rational functions, rational equations, right? So that's equations where we dealt with things like 1 over 2x minus 3 over x is equal to 5 over 4. And we were solving those. Do we remember those? Right? From the last test? Okay? It's these kinds of problems, but story problems. Oh yeah. Good times. So, what I have in the packet is it gives you some examples. The first few pages are examples, and then there's a couple of pages of problems. You're going to work 2 of them for tomorrow. Then, not tomorrow, but Friday. On Friday, you finish your quiz, and we start talking about the work that you did in this packet and in the book, and you get the exam review, and we kind of hammer out any issues that you have, and we test on Monday. Okay.